We're now going to look at sample size. And so I'm going to set the null hypothesis to 100. The alternative hypothesis I'm going to set to 105. Alpha I'll keep at 10. N is going to stay at 16. So we can see we've got D is 0.5 and power is 0.639. So I'd like you to anticipate. So have a look at our diagram. I'd like you to anticipate how the picture is going to change if the sample size is changed from 16 to 50. What happens when we move that over? So so you think about it and we'll change it. So what's happened here? The power has gone way up. It was at 0.639. It's now at 0.971. The D has stayed the same at 0.5. Alpha stayed the same all along, but beta and power have changed. So power has gone way up when we make our sample size larger. So why is that? Well, what you can see is with that distance, the spread has got, let's go back again and we'll have a look again. You can think about what's changed when sample size goes small again and when it goes large again. So you can see that that changes, and then I can also change the sample size by dragging this up and down. So you can see it gradually changing. It's easier to tell. So our standard deviation is not changing, but because n is changing, the overall spread seems to change here. Okay. So we end up with more or less crossing that line of each of them. Okay. So as alpha, you can also see is not actually changing because we're keeping alpha steady. So our line is changing, is what's happening. Okay. All right. So let's have a look. If I changed n to 4, what is the power when n is 4? There. So you can see power is 26%, and beta error then would be 74%, as we can see there. So 1 minus 0.26. Okay, what we are going to do now is look at the effects of the impact of standard deviation. So I'm going to go back to the high power settings of 100 and 110. And we're going to keep standard deviation at 10, alpha at 0.05. Oops, sorry, alpha. Oh, there we go. Alpha at 0.05. N is going back to 16, so we'll start right from scratch again. And note, remember the power is about 99%. What's going to happen if I change my standard deviation to 20? So I'd like you to predict that, and here we go. So as you can see, we've got a reduced power. What happened to our diagram again? Let's go back to 10. Okay, so that the D is 1, so a total of a distance of 20. Oops. Okay, so our scale has changed here because our 2 points are the same actual distance apart, but D is 0.5 now because it's 0.5 times 20. And that is the That's our Z that gives us our alpha at 0.05. So as you can see, it reduced our power and increased beta. So that's, once again, it's hard to see that these two are the same distance, but the net effect is power decreases, beta increases when we change our standard deviation. So what we're doing is spreading things out more. Okay, what's the impact of alpha? So I'm going to go back to our low power, set this at 105. Standard deviations is 10, and n is going to be 16. So here again we get about 64% for our power, and D is 0.5 again. So what do you think is going to happen now if alpha is reduced from 0.5 to 0.01? So I'm tightening up my significance level. And so from our power of 64, the power has dropped to about 37. So by having a smaller alpha, the blue part here, that moved this red line further to the right, which means we're going to have a bigger beta and a smaller power. Okay? So we're going to jump back to our notes and summarize what we've learned here. Okay, so let's have a look at what we've discussed now. So the summary that we have, and you can copy this screen part down, we've got 5 interrelated concepts that we've learned from our little simulation. They are the beta error, and that gives us our power. Remember, the beta error is the probability of a type 2 error. The effect size is the difference between the means, and the larger effect gives a greater power. So in other words, as the difference between our alternative correct and our null hypothesis, as they go up, the power is going to go up. And the chance of a poor decision is going to go down. Okay. The alpha error. So B is beta, A is alpha. The alpha error is a concept that affects here in that a smaller alpha produces a larger beta error and a smaller power. So that shifted that dotted line. Okay, n is the sample size, so a larger sample size gives a greater power. And S was the standard deviation. The greater standard deviation gives less power. So some of these we don't tend to have a lot of control on when we're conducting a significance test. The one that we do have, if you're designing a study, you might be able to control some of these, but the one that you would have the most control over would be to increase the sample size. And by increasing the sample size, not only are you decreasing the probability of a type 1 error, which was, recall, alpha, and a type 2 error, which was beta, but you are also increasing the power of the test. And that, of course, is a good thing. Once again, why wouldn't we have the biggest possible sample size? Well, that depends on things like cost and how many, if you're losing samples in order to do the sampling, how much loss you can afford out of your population, and other factors such as that. All right, that's the end of the lesson on power. What I would like you to do for homework from section 9.1, you were already assigned numbers 1 to 21 odd. I would like you to add numbers 23 to 25 odd, of course, plus the multiple choice questions. Okay, have a good time with that.